Welcome to this new video on Strands agents. And today we are going to build an agent that can use the entire Google search engine as a tool. In one of my previous videos, I will link this somewhere here above, we have built a set of agents that could use very simple tools that perform calculations or do data processing. One of these functions was this generate random number function, which basically just took a bunch of parameters and then returned a random number from a given interval. Now, in this video, we are going to access an external API, the Google API, and I will show you in the next 10 minutes how to do that and how to build a rather powerful agent that can actually use Google to get information and try to find better answers using Google, but also can find information that is not available in the training data of the large language model, and therefore would either get you a hallucination if you would just ask the large language model, or it would give you no answer at all. So let's build an agent that can use Google. The function that does all of this is on this slide. It uses the custom search engine by Google and the SDK that is provided with that. It sends a search string to Google and then returns the result. Similar to the last video, we are using this tool decorator here, and then we have two parameters. One is the actual query string, so something that you would put into Google, and then the number of results that we want to have returned. Google will give us the results, and we will just return those as a string to the agent, and the agent will then perform its magic, so to say, to get a coherent response out of this. Now, if you want to follow along, the code for this video, just like the other ones, is on this GitHub repository. There's this QR code, which you can use to access the GitHub repository or this URL. In any case, feel free to hop along and download the code, and then I will see you on the other side of this in my Visual Studio Code to run through and explain the code. Now, if you've downloaded the code, you will get a bunch of notebooks. And today we are going to focus on the number 3 notebook, Web Search Agents. This notebook basically implements the agent that can Google. Similar to the previous videos, we are going to install a bunch of packages, Python packages first. And the new package that we are going to install this time is the Google API Python client. That's just a Python client for using the Google API. The tricky part of this is setting up the Google Search API. You first need to click on this Google Custom Search API link here and get a key so that you can authenticate to the Google API. Let me show you what you will see there. You will see the Custom Search JSON API introduction, and this website has a button that says get a key. And if you click on this button, you are going to face this pop-up here. You have to give it a name, and then you click next and you get a key. Important, the key is only displayed once on the screen, so you better copy it. And the way you should do that is you should copy it and open a new file. In this case, name this file google-api-key.txt. You store that key in that file, and I've done that for myself. So there's this file here, which has the key that I'm using for my Google Search API. The second piece is that you need to get a custom search engine up and running. So let's call this tool search engine. And the important piece here is the default is search specific sites. We want to search the entire web. And then you also need to confirm that you're not a robot. Once you click create, you also get an ID that is unique to your search engine. So Google can find the search engine that you're querying. This search engine ID needs to be put into another text file. I've called this google-search_engine-id.txt. Copy paste that and store that file. Once you've done that, you are good to go. We can use the Google API, run this second cell, and if you get the green tick marks, everything is good. Now, the next piece is again the authentication to Bedrock. In this video, we are going to use the Bedrock API. In one of the next videos, I'm going to show you how to use Olama so that you can run the large language model on your own computer. But for this one, we are going to stick to Bedrock. If you're using a Bedrock API key, you just put that in between these quotation marks. If you want to know how exactly you are going to get such an API key, there's a video that I will link here, and then you can use that approach. I will use a different approach. I have a CLI configuration on this computer, so you can actually use a CLI profile. That's another way how to do it. And we will get the tick marks again, either from the API key or the CLI profile. Now let's get to the implementation of the tool. I've shown you the short version of the implementation and the most important lines on the slide already. So we have the tool decorator, we have the Google search function that we are going to use. This is the parameter that is the query string. The number of results is the number or the maximum number of results that we want to get from the search API. Those two parameters are then used to build a custom search object. And once we have that, we can execute the query. Once we've done that, we get a result and we format those into a list of strings. And the strings basically contain the title, the URL that is associated with the Google search result, and the description. That's the short text snippet that you usually get underneath the Google search result. So that's it. Now let's test this. And before we go and do this with an agent, we do this without an agent. So we are just going to use the function to query Google. And in this case, we are going to send latest AI developments in 2024. You can also Google that yourself, and you will get a result that in this case just has two entries. The first one is from McKinsey and the second one is from channelinsider.com. So both of these results are what we get from the search engine directly. This is the formatting that our function returns. So as noted, we have a string that basically says, hey, this is the title, the URL, and a bit of a description. Now, let's create the search agent. And the search agent and the creation of it, that should be something that you are familiar with if you've seen any of the previous videos. The search agent is basically told, hey, you are a helpful research assistant. When you are going to use the Google search, then you need to have, like, for example, current information on news, facts that may have changed, and so on and so on. And we all also tell the agent that it should always cite the resources with the URLs. And we will see how this changes the behavior. Most importantly, we provide our Google search function as a tool to the agent, so the agent can actually use this. So there's not really a lot new going on here because we've seen the similar structure in one of the previous videos. For example, for the random number tool, we've done a similar approach with just a different system prompt, but the tools list here is the same. Now, let's test this with a bunch of different queries. The first one that we are going to query is similar to the query that we directly sent to the Google search engine. What are the latest developments in AI in 2024? So it will look this up, and then we are also going to ask it what the current weather is. What's the current weather in Tokyo? So both of these requests are something that the large language model on its own would most likely not be able to answer, or it would start hallucinating. In this case, for example, the current weather is something that's not in the training data, so you would most likely get something that is hallucinated. Now, if we look at the results that we get from the agent, first of all, is using the Google search tool. It gives us a summary of the information that it received from Google. It gives us, for example, sources from MIT, from Yahoo Finance, from McKinsey again, from Forbes, and also from the Google blog. This is a very nice way of getting summaries of search results out of Google. Now, the second one, what's the current weather in Tokyo? It requires a bit more research. And actually, the agent used the tool 3 times to properly search for weather information in Tokyo. But it found the result. It shows us that there's 81 degrees of Fahrenheit, that's 27 degrees in Celsius, so pretty warm. And then it provides us also some additional information, and it cites AccuWeather and weather.com as the sources. So as you can see, we can get really nice results and summaries using this agent. The thing that we need to understand is the impact on performance. The next cell gives us an insight into this. When we call the tool directly without the agent, then we would get the result pretty quickly. Usually Google returns the result in less than a second. With the agent, this takes a bit more because the agent needs to involve the large language model. It needs to get the right query to the search engine, then get the result back to the large language model. The large language model then does something to summarize it, and so on and so on. So this takes a bit more time. And if we look at this, then we can basically see that for this query, we had, with the direct tool usage, we had about 0.9. With the agent call, we had 17 seconds. So there's a significant overhead here between the direct tool use and the agent. And the reason for this is the large language model. So usually the large language models respond in the order of seconds, whereas the direct tool call is, again, less than a second. Another point that I've made in previous videos is about error handling. The Strands SDK does a very good job at handling errors and finding ways how to successfully complete a query from the user or the programmer. The examples that I'm using here is, again, an empty query. So how does it handle it? How does our Google agent handle an empty query? How does it handle a nonsensical query, I would say? And then how does it handle a special Google feature, which you can use to restrict your queries to a certain website? And what happens if that website does not exist? So that's those are edge cases, and those edge cases need to be handled. And usually you would need to handle them on application code, but the Strands SDK handles them quite nicely. In the first case, basically tells us, hey, I'd be happy to with a search, but you need to provide a search query or a prompt. It doesn't give us an exception or anything. It handles this quite nicely. Then the nonsensical query, it basically provides us the result that Google has given it, but it also tells us that this is most likely something that doesn't make any sense. Appears to be a combination of all letters from a certain keyboard layout with 3 sequential rows, and that's basically it. And then the other result here for the non-existent website is that it returned no results. It says, hey, there are no results here, and the domain appears to be non-existent. So it gives us a pretty detailed response for why this query doesn't result in a good response. In the previous video, I've given you some homework. And in this video, I would encourage you to play around with this research agent, which is another implementation that uses this Google search tool. And it's a research assistant that will use Google for researching on a topic. You can play around and use different topics here. The proposed topic that I've taken here is research the impact of AI on software development in 2024. And it provides you with a bunch of different angles, also about future trends and predictions, and it will write you kind of a report. So this way you can use the power of large language models and Google try to get information and a report that summarizes that. With that, I would ask you to first of all, maybe leave a subscription or like this video. And if you have a comment, a question or anything, leave that as well. I will try to answer. With this, I would like to thank you for your attention and go build.